Hello YouTube, RJ. If you caught my last video, we're working on the LT1010, ran into a few little issues, found out that just using a voltage divider from resistors fed into the LT1010 to get my split rails wasn't working very well. So as I found out in the last video, it really needs a pretty stiff voltage divider. And so that 10K voltage resistive divider I was using just wasn't cutting it. We did get a little better when we went down to 1K, but you know, I don't want to waste that much power from the battery. I really want this to work well. So I went ahead and backed up, and what I've done here on the board is I've put an LM358 op amp in here, just a basic op amp. And what I've done is I've got it set up into a voltage follower or unity gain buffer or whatever. You know, there's a dozen terms people use for it. But basically an op amp that whatever voltage I put in, it puts out, but it buffers whatever the input is. So since our resistors have not a very stiff drive, this allows it to pull almost no current. As you know, if remember op amps. Let me put the schematic up here of a voltage follower. Here's it's very simple. Here, I'll put it on screen. Basically, whatever goes into the input of the op amp will be matched and output on the output, but the difference is it's buffered, it's isolated, so there's no current draw. If you remember your rules on op amps on the inverted and non-inverted input virtually pull no current. So there's no load going on this voltage divider here. The output then is pretty stiff. The op amp's output voltage is going to match the input, which is the middle of the divider. So it should be roughly half of the battery voltage. The LT1010 is not going to push around. So with that in mind, I'm using just what we did before. I've just removed the two resistors for the resistor network. I've soldered in a wire to pick up over on my voltage follower. We're going to check this out. So I've got 30 volts going in, and I'm set up on the bottom meter here, and let's see what our positive output reads. And it looks like we've got 14.952, and our negative is going to be negative 15.052. So pretty close. The resistors are not exact. Now I had some suggestions, some actual quite good suggestions. One suggestion that come up was that I could put a potentiometer in place of a resistor, or a trim pot, I should say, and be able to trim this, you know, right up perfect. Unibyte suggested this, says he does that. I'm not worried about it being exact. It doesn't matter if it's a little off. What matters is it's reliable, and as the voltage changes, I'm not going to see a variation between the supplies, you know, the negative going farther off than the positive. I'm not worried about that. With 1% resistors in there, we'll be fine. So the voltage looks really, really good here. I'm going to lower the voltage down. We'll check it again. And then what I think I'm going to do is I'm going to off camera go ahead and step through each voltage from say 30 to 24. And I'll plot it out, and we'll see how linear it is, how much it follows the change in voltage of the battery, and see if this thing is going to be what I'm looking for. Give me a minute to do that, and then we'll look at how I've redesigned the circuit in our actual voltage calibrator to take all this in. Okay, so I've completed that, and here we'll pop up and show you the chart we came up with. And as you can see, it's quite good, actually, very good. It's within the tolerance of my measurements on the meter, actually. Looks like it follows the battery voltage. Now you're looking at battery voltage divided by 2, half the battery voltage. That's not the actual voltage going in, that's half exactly half calculated, and that way we can see how well these track along it, and as you can see, it's quite good. So I'm very happy with that. So now let me just show you the schematic. Here's what the power supply for the voltage calibrator board is going to look like now. You can see I've added in an op amp, and just as we did on the proto board here, and you can see that that's how we're going to get our voltage to give us that center reference for the positive and negative. And so that's going to work very, very well for us. Pretty short video this time. I hope you learned a little something. I know I have. And I hope most of all that I'll see you in the next video.